For this next problem from chapter 10, we have the probability of the sum of three 8-sided dice being 19. Well, first, let's define our event space, or that is the number of ways that this could happen. Well, if I have three independent 8-sided dice, then that's going to be 8 cubed, or 512. There are 512 ways for me to roll this die, these die. So the question is, how many of them will add to 19? What I'm going to do is I'm going to list ordered triplets. Okay, so I'm going to make sure that they're ordered, and I'm going to then count up how many ways I can get each of those ordered triplets. There's really no methodical way to get all of these. You just have to play around with the numbers a bit. I'm going to start off with what I consider to be the lowest of the triplets. That is, it's the triplet that has the lowest number. If I have two 8s, that is 16, then the lowest number I can get is 3. There's no way I can roll a 2 or a 1 and get 19. Just not going to happen with 8-sided dice. I'd need 10-sided dice or something like that. Now from here, to create new triplets, I'm going to borrow a number from one and put it onto another and see if that works. Alright, so I can't borrow anything from the 3. That would make it 2 and give it to the 8s because the 8s are as high as we can go. Well, we can take a number from an 8 and put it on the 3. That'll give us a 4, a 7, and an 8. And that's the only way that we can go from this triplet to this triplet. It's the only way that this triplet can give us another triplet. Now here, I can take one from the 4 and give it back to the 7, but that'll put us right where we started. I can take one from the 4 and put one on the 8. No, I can't because 8 is the highest. So the 4 is out in terms of giving out numbers. I can take one from the 7 and give it to the 4. That will give me 5, 6, and 8. Or I could take one from the 7 and give it to the 8. Again, that's not going to happen. I can take one from the 8 and give it to the 4. So that'll give me 5, 7, 7. Or I could take one from the 8 and give it to the 7. That would really just switch it. I don't consider that a separate pair. So this one is done in terms of generating new pairs. Then looking at this one, I can take one from the 5 and give it to the 6. That would put me right back where I started. I can take one from the 5 and give it to the 8. Nope, can't do that. I can take one from the 6, give it to the 5. That would just switch them around. I could take one from the 6, give it to the 8. No, I can't. Take one from the 8, give it to the 5. That would be 6, 6, 7. Well, I don't see that one anywhere around here. So that gives me 6, 6, 7. Okay, that's a new triplet all unto itself, and there's no other way for me to create a triplet from this group. Now looking at this one, I'm pretty sure that we're pretty exhausted here. 5 can't give to either of these 7s without repeating this. 7 can't give to the 5 without giving us this. So this one's exhausted, and you can't take one of the 6 and give it to the 6 to the 6. That'll give you this triplet. Can't take one from the 7 and give it to this because it'll just stay the same. So I think these are all of the triplets that we could possibly create. How many times could we roll each triplet? Well, that requires permutations. This has 3 numbers, so we're inclined to say 3 factorial, or 6 ways to roll it. But 2 of them are duplicates, so I need to divide out the repeats. That's equal to 3. So there are 3 ways for me to roll this number. You could think of each one. There's 388, 838, and 883. 478, because those are 3 different types of number, is just going to be 3 factorial, which is 6. Then 568, similar to 478, has 6 different options. 577, similar to this one, has 3 options. And 667 also has 3 options. add all these up, and we're going to get 3 and 6 is 9, 9 and 6 is 15, 15 and 3 is 18, 18 and 3 is 21. So our total probability of the 19 is equal to 21 over 512, or about 0.041 or 4.1%. So pretty low chance, considering that the highest that you could roll would be a 24. Getting a 19, which is pretty high up there, should be pretty low percentage odds. So there we are.